Welcome! Algebraic expressions, equations, identities, and formulas are integrated so well into our lives, and yet we hardly notice that they are there. They play a key role in generalizing mathematics. We could not simply solve and understand many things without them. This is why these are incorporated in GCSE math syllabus and is one of the most important content you'll ever learn. This video will show you how you can express problems in mathematical context and solve them. Before we move on, please support this channel by clicking like, share and subscribe button so that you don't miss out on any one of my latest tutorial videos. Your support will go a long way and help others who really need this support. Let's say we want to add 2 with 1. We know that answer is 3. And similarly, we can add 5 with 7 to give 12. And we can make lots of these sums, subtractions, divisions, multiplications, and so on for any given numbers. But when you want to generalize, let's say, the addition of the two numbers, we need algebra. If we let x be any number and y be another number which is different from x, then we can generalize these sums to x plus y. This is an example of algebraic expression. It's easy to identify these algebraic expression as they contain at least one letter and it does not have an equal sign. When the problems are written in algebraic expression, we are able to add, multiply, subtract, divide, and factorize the unknown quantities with ease. This makes the problem simpler and easy to understand and also help it to solve it. Let's say cost of hiring a bike is £5 per hour and fixed cost of £10. If we hire the bike for 1 hour, we pay total of £15. And if we hire the bike for 2 hours, then we have to pay £20. Now, if we denote the number of hours with letter X, we can begin to generalize the cost of the bike hire. This will be an algebraic expression 5x plus 10. This expression can tell us the total cost of the hire for any number of hours X, as X can represent any number of hours in this expression. Let's now suppose that the total cost of the hire is denoted with letter C. We can then write the total cost of the hire as C equals 5x plus 10. This is now an example of the formula. C only appears once on the left hand side of the equation, so C is also known as the subject of the formula. Formulas are basically a set of instructions for working something out. They always have at least two unknown letters. This formula tells us how to find the total cost of the bike hire C for any given number of hour X. So if you want to hire the bike for say 6 hours, formula tells us to multiply the number of hours, in this case 6, by 5 and add 10 to give the total cost. So this gives total cost of £40. If you hire it for 10 hours, we substitute 10 into the formula and we get the total cost of £60. In GCSE Maths, you'll encounter many different formulas. For example, formula for finding the area of rectangle is given by multiplying the length L with its width W. Formula for finding the area of triangle is the height times base divided by 2. And area of a circle is given by pi times r square, where r is the radius of the circle. Sometimes the subject of the formula are not quantities that you want to calculate. For example, if we know or given the total cost of hiring the bike but want to find out how many hours we can hire the bike for, then this is when you need to rearrange the formula to make the number of hours X the subject of the formula. In order to change the subject of the formula, we must always balance the quantities on both sides of the equation. We start by subtracting 10 from both sides of the equal sign. This gives us C minus 10 equals 5x. Now we divide by 5 on both sides of the equation to give x equals C minus 10 over 5. We have now made x the subject of the formula successfully. If we now have £90 to hire the bike, we can work out the number of hours you can hire the bike for by substituting the value of C with 90 into the formula. 10 subtracted from 90 gives 80 and dividing 80 by 5 gives 16. Therefore, we can hire the bike for 16 hours with £90. Alternatively, we can substitute the value of c in the original formula and solve for x. This is now an example of an equation. Equations have equal signs and the unknown values, which requires solving the equation to find these unknown values. We can make x the subject of this equation to solve it. We first subtract 10 from both sides of the equation. This gives us 80 equals 5x. Then we divide by 5 on both sides of the equation, and 80 divided by 5 leaves us with 16, and 5x divided by 5 leaves us with x. Therefore, the solution to this equation is x equals to 16. On this particular case, x can take the value of 16 to satisfy this equation. It means that we can only hire the bike for 16 hours with that amount of money, and no other values are possible for x, given that we want to spend all our money for hiring the bike. Hence, there are no other values that satisfy this equation other than 16. This particular equation is known as linear equation, and they only have one answer. There are other types of equations that you will encounter in your GCSE maths. One of the most famous one is the quadratic equation, which have at most two solutions. For example, x squared equals 9 is an example of quadratic equation. This equation has two solutions, as 3 square is equal to 9 and minus 3 whole square is also equals 9. These are the only two values that satisfy this equation. Other equations such as simultaneous and exponential equations are also regularly featured in GCSE math exams. Now let's suppose that we want to factorize the expression for the total cost of the hire 5x plus 10. As 5 is common factor of the term 5x and 10, we can factorize this number out, which leaves x plus 2 inside the bracket. This expression is now identical to 5x plus 10, or equivalent to 5x plus 10. This is an example of identity. This might confuse you because they also have the equal sign like the equations. However, the important difference here is that equation only have a set number of solutions for x, while identity is satisfied by any values of x. For example, if we substitute x with 2 on both sides, this gives us 20 on both sides. This satisfies the expression on both sides of the equation. If we put 3, this gives us 25 on both sides of the equation. Therefore, x equals 3 also satisfies the equation. In fact, we can put any value for x, and this will always be true. Identities are satisfied by all the values of x. Normally, we must put this symbol to show that left side of the expression is identical to the right side of the equation, but we usually don't use this symbol so often, so they look like equation to untrained eyes. For example, can you tell whether this is equation or identity? In order to check this, we can substitute x equals 0 on both sides. This gives us 1 on the left and 3 on the right side. The equation is not balanced, so this cannot be an identity, and so it must be an equation. There are some important identities that you will encounter at GCSE Maths. For example, take a look at this shape. Total area of this shape is x squared. If we now delete the green area, we are getting rid of y square amount of the area from the total shape. So the expression for remaining shape is therefore x squared minus y squared. If we now reconstruct the rectangle with just the remaining two shapes, its total area could be expressed as x plus y times x minus y. Therefore, this must be equivalent to the difference of two squares, as they represent the same amount of area of the shape. We can also prove this algebraically by opening the two brackets. Multiplying this out gives us x squared minus xy plus xy minus y squared. But minus xy and plus xy cancel each other out, leaving us x squared minus y squared, which means the two brackets are identical or equivalent to difference of two squares. This identity can be used to factorize other expression that can be written as the difference of two squares. For example, a squared minus 4 can be written as a squared minus 2 squared, as 2 squared is equals to 4. This is difference of two squares, and we can simply factorize using the identity to give us a minus 2 and a plus 2. We can sometimes even calculate subtraction of big square numbers with these identities. For example, if you want to calculate 100 squared minus 99 squared, we can simply apply the difference of two square identity to put them on a factorized form. Calculating the first bracket gives 1 and second bracket gives 199. So multiplying together gives 199. So therefore 100 square minus 99 square is equals to just 199.